Along with domain and range and functions, we need to talk about symmetry. And we have three different types of symmetry. We have symmetry with respect to the x-axis, to the y-axis, and to the origin. These are your book definitions, and you need to write in these ordered pairs. But a graph is symmetric. This stands for with respect to the x-axis if for every point x, y on the graph, the point x comma negative y is also on the graph. And you can see that visually here. You've got x, y. Well, that x down here is the same, but now it's on the negative y. So everything kind of mirrors each other in that way. So if a graph is symmetric with respect to the x-axis, then the point 3 and the point 32 is on the graph, then the point 3 negative 2 is also on the graph. When we have symmetry with respect to the y-axis, these are called your even functions, and this is what we're going to be talking about in lesson 8. So you don't really need to know that now, but just a little clue, I guess. A little preview, that's what I'm looking for. A little preview as to where the next lesson is going. When you have respect to the y-axis, these are your even functions. And a graph is symmetric with respect to the y-axis if for every point x, y on the graph, the point, this is supposed to be negative x, y, is also on the graph. I wrote that in the wrong spot. And again, you can see that on our example over here. You've got x, y over here. Well, here, when it reflects, the y coordinate doesn't change, but now the x does. So if a graph is symmetric with respect to the y-axis and the point 32 is on the graph, then the point negative 3 positive 2 is also on the graph. And I probably should have came over here and explained these. So let me back up and talk about when we have symmetry with respect to the x. Notice here that you have that x-axis here. Think of this as a mirror image. You're taking whatever the image is here, and if you take it and reflect it or mirror it over here, it's going to land on top of each other. You think of those like little ink things you used to do in art class or that you see on all of the TV shows and movies. If you paint something and then you fold it in half and now it's the same on both sides, that's what we're doing here. We're folding that over and it's landing on top of it right over here. So when it's with respect to the y-axis, it's the same thing, but now it's flipping and folding over here along the y. And so this point would land right here on this point would land on this point over here when you take it and reflect it. So think of this as your mirror. So we have some symmetry with respect to the origin, and then your preview for that is these are called odd functions. And it's a graph. A graph is symmetric with respect to the origin if for every point x, y on the graph, the point negative x, negative y is also on the graph. So if a graph is symmetric with respect to the origin and the point 32 is on the graph, then the point negative 3, negative 2 is also on the graph. Okay, so now this is going to ask for what we talked about in the last video. Is it a function? What's the domain? What's the range? We're going to talk about intercepts, and then we have to list if it has symmetry with respect to the x, the y, and the origin. And again, I forgot to explain this picture, so let me go back again. These are a lot easier to see because you can see them reflecting, right? This one's reflecting over the x, this one's reflecting over the y. You've got the mirror images of each other. When you have something over the origin, it's like it rotates. It's not like it rotates. It does rotate 180 degrees. So you can see this pink portion of the graph right here. If I was to take my paper and rotate it 180 degrees, this now looks the exact same. Or you can take this whole thing and look at this entire graph If you take the entire graph and you rotate it, it now looks identical. Okay, so that's how you can tell if it's origin symmetry. So for these problems and 4 more on the next page, we need to determine whether or not the graph is that of a function by using the vertical line test. So we'll answer yes or no here. In either case, use the graph to determine the domain and the range and the intercepts, if any, and indicate whether the graph is symmetric with respect to the x, the y, the origin, or none of these. So we just need to answer these 5 questions. And before we do, let's talk about what intercepts are. That's something that I thought everybody kind of knew, and it turns out we don't. So what intercepts are, you can have x-intercepts or y-intercepts, and what those are is where this graph is crossing the x-axis and where it is crossing the y-axis. Okay, those are what your intercepts are. So when they give you points over here, right, you've got -1, 2, and you've got 1, 2. Those aren't intercepts because it's not crossing either of these major axes, your x-axis or your y-axis. You're wanting to look, where is it crossing the x and y axis at for your intercepts. Okay. So first off, is this a function? If I use my vertical line test, does it pass the vertical line test? Yes, it does. So yes, this is a function. When I put a vertical line, it does not cross this any more places than 1. So what is the domain? Domain is x. We're going to determine that from going from left to right. So as I take my pencil here, or I guess my pen, and I go from left to right, the first thing I touch right here is an arrow, which means this is -infinity. And as I keep going from left to right, the last thing I also encounter is an arrow. So this is to infinity. My range, we will go from the bottom to the top. So as I go from bottom to top, the first thing I encounter are both of these arrows. So we get -infinity. And then the last thing I encounter is this line right here. So the highest point is right here at 2. 2 is included, and so we will put a bracket. Basically, when you're doing domain and range with interval notation, every number is going to get a bracket and parentheses for infinities. That's not always true, but mostly true. And then intercepts. Is this graph crossing anywhere on my x-axis? It's crossing right here and right here. So those ordered pairs are 3, 0 and -3, 0. And is it crossing this y-axis anywhere? Yes, right here at 0, 2. When you're putting this in my math lab, you have to make sure you put parentheses between your ordered pairs or you will get that wrong. So just heads up there. And then does this have any kind of symmetry? Does it have x-axis symmetry? Okay, if you fold this over, it's not going to land on top of each other because this is going to keep going down. So it's not mirroring along this x. What about the y? Does it mirror along the y-axis? Yes. If you take this graph and you fold it over, it's going to land on its other side. So with respect to the y-axis. Now, once you find one, you can't stop there because you could have multiple. So also look for origin. If I take this and rotate this 180 degrees, does it look the exact same? No, it doesn't. So it only has symmetry with respect to the y-axis. Okay, let's do 4 more examples answering the same questions. So first off, is this a function? Yes, it is. You put any kind of vertical line, it's only going to intersect once. What's the domain? Domain, we go from left to right. So as I go from left to right, I first encounter the graph right here, which has an x coordinate of -pi. And then what's the biggest x coordinate I get? Well, it ends right here at pi. Those numbers are included, and so we get brackets. The range, we go from the bottom to the top. So as I go from bottom to top, I first encounter the graph right here. What is that y value with this graph? Well, it's right here at -1. And then as I go up, this is the highest my graph goes, right there at 1. Intercepts. Is this crossing my x-intercept? At 3 spots. Here, at -pi 0. Right here at the origin, comma, at 0, 0. And then also right here at pi 0. Is it crossing this y-axis anywhere? Yes, right here at the origin, which we've already included. Okay, let's see if this has any kind of symmetry. Does it have x-axis symmetry? If you take it along the x-axis and mirror it over, does it land on top of each other? No. How about on y? If you fold it over here, does it land on each other? No. How about if I rotate it 180 degrees for some origin symmetry? That looks the exact same. This has origin symmetry. Notice it goes down and then goes up. Here it goes down and back up. So this has symmetry with respect to the origin. Okay, on C, is this a function? No matter where you put a line at on here, it's going to intersect twice. So this is not a function. Okay, what's the domain? Go left to right. As I go left to right, the first thing I encounter are these arrows. So we've got -infinity, 2. What's the last thing I encounter? There's some more arrows. So to positive infinity. I'm going to erase this. The range is a little bit more tricky. Notice that when I did the range, there was no breaks, right? These lines were continuous. I never left either of those two lines. When I do the range though, I hit it, and then I'm not on it, but then I hit the graph some more. So we're going to have two separate ranges, or I don't know how to explain that, but we're going to have two sets of parentheses to represent this portion down here and this portion down here, because we're missing some y's right here in the middle of them. So when I go from the bottom to the top, the first thing I encounter are these arrows again. So we've got -infinity. But then what's the top of this portion here is boop, right there at -1. I've got two sections, so I'm going to put the union in between. And then the second portion, where's the smallest that we hit, is right here at 1 again. And then as I go up, what's the last thing I hit are both these arrows. So infinity. Do I have any intercepts? So is this graph crossing this x-axis here? No. What about this y-axis? Yes. We have a point here, and we have a point here where it is crossing my y-axis. So those ordered pairs is 0, -1, and 0, 1 for this one up here, comma in between. And then here, do I have any kind of symmetry? So do I have x-axis symmetry? If I take this over here and I fold it over, is it going to land on top? And yes, when you take this and you fold it over, it's going to land right there on top of that bottom portion. So we have with respect to the x-axis. Don't stop there because you can have multiple kinds. What about if I reflect this along the y-axis? Is this going to land on top of each other? Yes, it is. When I flip this, this lands perfectly on top of the other half of my graph. So y-axis. And then don't stop. If I rotate this 180 degrees, do I have origin symmetry? Does it look the exact same as it did right side up? Yes, it does. So this one has to the x-axis, to the y-axis, and the origin. It's got all three types. Okay, why don't you guys try pausing the video and doing D on your own? Okay, once you go through the 5 questions here, hit play and see if you got them right. Okay, I hope you paused the video, so let's check your answers. We should have got no, this is not a function, because when you put a vertical line through here, it touches this twice. Okay, so this is not a function. So then domain, we're going to go left to right. When I go left to right, the first thing I hit are arrows. So negative infinity. And then the highest number it touches is right here at 0. My range, when I go from the bottom to the top, the first thing I touch is an arrow. The last thing I touch as I go up is another arrow. So this has negative infinity to infinity, which, by the way, what this really means is that my range is all real numbers. And then intercepts. Is this crossing my x-axis in any place? Right here at 0, 0. Is it crossing your y at any place? Same spot at the origin, and we've already got that. And then does this have any kind of symmetry? Does it have x-axis symmetry? If you take this and reflect it over, does it land on top of each other? Yes, it does. So this should be with respect to the x-axis. What about y? I guess we'd have to take it here. Does that reflect and map onto itself on the other side? No, because there's no graph over here. And then origin symmetry, that looks different. So only to the x-axis. Okay, and then last one here. And if you want to go ahead and pause the video again and try this one. This one's a little bit tricky, but you got to be able to do this. So pause the video and then hit play to see if you got the right answers. Okay, I really hope you paused the video. Let's check your answers. This is not a function because when you put a vertical line, you're going to hit it twice. The domain, okay, these actually have arrows going on both of these here. And this one's tricky because we haven't really learned much about it, but you're gonna have one similar to it on your homework. These are considered rational functions. And you have an asymptote here, which means it's going to approach it, but it is never going to touch it. And same thing that's going on here. You have another, this time horizontal asymptote right here at y equals 0. So these lines are going to get closer to that line of y equals 0, but they're never going to touch it. This line up here is going to keep going and get closer to x equals 0, and this is going to keep going and get closer to x equals 0, but again, never touch it. So my domain here, when I'm going from left to right, the first thing that I hit are these arrows. But that is not infinity. Because as I said, this is going to keep going up. This is going to keep going down. It's going to get close to 0, but never actually touch it. So your domain here is 0. But then on these, when I hit these arrows for the last time, these are infinity. Okay, so these two arrows here for 0, because it's approaching an asymptote, it's never going to touch it. It's never going to cross it. And so that's why this one here is tricky, because if you don't know that this is a rational function and that it's approaching an asymptote, you're going to do negative infinity to infinity, because I have taught you arrows mean that. Okay, but we have asymptotes here. And then your range is similar. When I go from bottom to top, there is a gap right here. So this bottom portion, when you go from bottom to top, we hit an arrow first. So that is negative infinity. And then as I am going up, I do hit another arrow, but that arrow is getting closer to 0. It will never cross that. It takes a break, and then it's going to jump up here. So union. And then from here to here, this arrow means it's going to approach 0 from the positive side. So we've got 0 here, and then it's going to keep going up forever for infinity. So basically your range is almost all real numbers. It just doesn't include 0. Okay, so then these you should have been able to answer. The domain and range were tricky with the asymptotes, but function, intercept, and symmetry you should be able to get. So does this have any intercepts? Is this ever crossing your x-axis? No. Is this crossing your y-axis? No. So we have none. We don't have any intercepts there. And then lastly, does it have symmetry? If you take this, will it reflect along the x-axis? And yes, it will. So this is with respect to the x-axis. Does it reflect along the y? No. And does it have origin symmetry? No. So only with respect to the x again.